Alright, now we're going to look at the Pythagorean theorem, where it comes from and when it can be used. I'm not going to go into depth about how to do calculations with this in this particular video. This is all the conceptual setup that you need before we get to the calculations. So the first thing you have to understand is that the Pythagorean theorem is all about triangles. In particular, triangles that are called right triangles. A right triangle is a triangle that contains a 90-degree angle. So a 90-degree angle is like an angle that forms like a perfect L, and you can see this angle right here does. That's marked with this little box, so anytime you see that little box, we know that we have a right angle. The other way of saying it is that this side is perpendicular to this side. They meet at a 90-degree angle. So again, this is just called a right angle. And the parts of a right triangle just being any triangle that has a right angle, they have some special names. So the first thing we're going to look at is this side right here. It's the longest side of the triangle, and it's the one directly across from the right angle. So if you think about if this was like a stool or a chair and you're sitting in there looking out away from the walls of the triangle, this side is going to be the wall you're looking at, the directly opposite of that. And this side has a name. We call it the hypotenuse. So I'll say that again so that you can see the spelling versus how that's said. This is called the hypotenuse of the triangle, and that's the longest side. Now we have two other sides that aren't nearly as long, and these are called legs. And knowing this now, we can start talking about what the Pythagorean theorem is, and I will use these terms hypotenuse and legs, so make sure you know hypotenuse is the long side, legs are the two short sides. Alright, so let's give ourselves this triangle here, and it turns out that for the Pythagorean theorem, we're going to give names to the sides. We're going to call the legs A and B. And it really doesn't matter which. We could call this B and this A, so the order of these really doesn't matter. Pick one. I called this side A and this side B. You're more than welcome to switch those. It won't make any difference. The hypotenuse, however, we always call C. And that one does matter. So A and B are the legs, and C will be the hypotenuse. And this leads us to this nice, simple, easy, but miraculous equation. A squared plus B squared equals C squared. So simple, but it describes these right triangles every single time and very elegantly. And this right here, that A squared plus B squared equals C squared, that is the Pythagorean theorem. And this is worth memorizing if you don't already have it memorized. Alright, now let's talk about some specifics on how this is used, when this is used, when it's not used. So I'll move my diagram over to the side here. And first thing you have to know and remember is that this only works for right triangles. If you don't have that little mark in the corner showing that one of these angles is a right triangle, you cannot use the Pythagorean theorem. Don't do it. It won't work. The next thing is that the use of this, like why the Pythagorean theorem matters, is if we have a right triangle, we can use the Pythagorean theorem to find a missing side length. So that is, if I know 2 out of these 3, if I know A and B, I can now find C. That's the whole purpose of this thing. If I know A and C, I can find B. So if I know any 2 of these, I can find the third. And then the reason this has caught on and has stayed with us and will likely always stay with us is that because of this relationship here, where if you know 2 sides you can find the third, we can actually use the Pythagorean theorem to find the length of any line, specifically on our coordinate system. So if I've got a coordinate plane and I've got a line across that coordinate plane, I can use the Pythagorean theorem to find the length of that line. Which we will get into in more depth later on.